All right, so it is 9 o'clock. We're going to get things rolling. Good morning, everybody. It looks like the vast majority of our class is not here. So, what we're going to do today is we're going to take a look at these two problems. So, these two problems are two problems that we did last class. So, we're just going to start with a review of that. And then, as you can see by the graphic at the bottom of the screen, we're going to be starting something new today. So, we're going to be talking about translations, which are part of transformations. So we'll take a look at that as well. Just remember, guys, if you have any questions, to use the chat to ask questions, to turn on your mic to ask questions. And if you miss anything, all of these videos are up on YouTube. All right, so we're going to go ahead and get started here. Again, I know a lot of you guys didn't get here in time to do the warm-up, but the warm-up is just a little extra piece, okay? So if you guys have questions, follow along, and please ask if you get stuck, okay? So if I'm taking a look at this first one, so this is what we talked about last time. So we want to find a value of x to make these lines parallel, right? To make them parallel, rather than the lines are parallel and we're just going to solve for something. So in this case, what we need to do is we need to take a look at the two angles and we need to figure out an angle rule. Now remember, all of your notes, all of these, everything that we do is open notes, right? So really what you need to do is you need to have your notes accessible so you can say, hey, what angle relationship is this? So if we take a look on this, both these angles are on the inside, right? So that's the key, right? They're both on the inside and they don't alternate. So these would be consecutive interior angles. Okay. So that's kind of your first step, right? You want to figure out, okay, what kind of angle relationship do I see? Then what we want to talk about is, okay, so these are consecutive interior angles, but we want these lines to be parallel. So then we get that angle rule involved, right? So we want if consecutive interior angles are supplementary, then parallel lines, right? So this is what we want. So we're looking at, we've identified what we're looking at. We're looking at consecutive interior angles, but if we make them supplementary, then the lines will be parallel. And that's what we're trying to get. We're trying to get them to be parallel. So supplementary, that means add up to 180. So I'm going to take these two angles and I'm going to add them up to 180. I get 3x plus x plus 20 equals 180 degrees. Okay, so again, the whole point here is that we're going to make them add up to 180 to find an x that makes them parallel, right? That's what we're doing here. So we were trying to find an x that makes them parallel. So I'm going to start by combining like terms. So I have 3x and plus x, that's a total of 4x, right? When they're on the same side, you combine like terms. And then we're going to go ahead and subtract 20 from both sides. So I get 4x equals 160 degrees. And then I divide by 4 and I get x equals 40. Okay, so that's what we're going for, right? If x equals 40, then these lines are parallel, right? So again, if x equals 40, then these lines have to be parallel. And this is really important when you're building something or you're designing something and you want parallel lines, right? You have to be able, okay, what will make them parallel? If this is this value, then everything is parallel. Okay, so that's one thing that we did last class. So I just want to make sure that we get to, if you came early, to practice it, and if you came late, just to see it one more time. Okay, the next thing, the other thing that we did yesterday was these proofs, right? These hashtag proofs. So I'm going to go ahead here and just go through this again. And maybe with some time between classes, right, it can help see what's going on. So with statements and reasons, can you guys in chat really quickly, what do I start with? What do I always write down first? All right, let's see if you guys remember from last class. So what always goes first in a proof? Heck yeah, you guys are on top of it. It's Friday morning, but you guys are super sharp. Right, I always have my given, and I'm going to have two givens here. So I'm going to have angle 1 is congruent to angle 3, and 2, I'm going to have that line R is parallel to line S. And my reasons for both of these are given. Okay, so I'm going to write those down. But also what's really important, right, is we want the visual as well. So I'm going to make sure there's, if I can, there's a visual representation of these. So it says angle 1 is congruent to angle 3. So I'm going to put a little arc there showing that they're the same angle. And then it says line R and line S are parallel. So I'm going to go ahead and add in a little arrow for both of those. Okay, so that way I visually can see, hey, these two lines are parallel. We don't know if these two lines are parallel. Okay, so that's always your first step, right? Your first step is to write down your givens and then update your diagram if you can, right, to help us with the visual. The second step is we're going to write a goal, right? So to get a goal of what we're trying to do, we have to take a look at, okay, what are we trying to prove? What's our end game? Well, we want to show that line J and K are parallel, okay? So remember, we only have 4 ways to show lines are parallel. That's what last class was about. So if there's only 4 ways, we need to figure out which one of those 4 we're going to do. That's our goal. Which one of those 4 ways are we going to show these lines are parallel? Now to do that, remember, they were angle relationships. So we need one angle on line J. It looks like there's 2, right? 1 and 2. And then one angle on line K. There's only 1. Okay, so having the problem tell us to focus on some angles really helps. Now, the one thing that we have to be careful about here, see how 1 is way up here in this upper left-hand city? There's no direct connection, right, between angle 1 and angle 3. Imagine, right, there's no road that connects me, right? So if I want to get from angle 1 to angle 3, I would have to go through another town, okay? So because there is no direct connection, there is no angle relationship between 1 and 3. So then that leaves me looking at 2 and 3. So looking at 2 and 3 here, I'm just going to circle them. Can you guys tell me in chat, what angle relationship is that? Right? And I can help you out a little bit. They're not on the inside. They're both on the outside. Yeah, and there's only one rule where they're both on the outside, right? Yeah. Oh my gosh, you guys are super. I'm getting lots of responses. I really appreciate this, guys, because the more you participate, the more I can tell if you guys are getting it or if we need more practice. These are definitely alternate exterior angles. Okay, so I have this angle relationship that connects line J and line K. So my goal here is if alternate exterior angles are congruent, then parallel lines. Okay, if I can show that these angles are congruent, that is, if I can show angle 2 is congruent to angle 3, then I have parallel lines. And if I have parallel lines, that's my proof, right? This is my proof. So to prove this, I just need to show that these two angles are congruent because they're alternate exterior. And if alternate exterior angles are congruent, then lines are parallel. So I got my work cut out for me. So I did step 2. Now, step 3 is the hard one, right? So I know where I want to go. So then I have to take a look at what I have. Well, I want angle 2 congruent to angle 3. But right now I have angle 1 congruent to angle 3. Dang, that means we're halfway there, right? I just, instead of the 1, I want 2. So we're going to have to find a way to show that angle 1 is the same as angle 2. And then we're good to go. So I look up here. And then, so the next thing I want to do is there an angle relationship between angle 1 and angle 2? So in chat, can you guys tell me, is this an angle relationship? Angle 1 and angle 2. We only got 4 of them, right? So you can have out your notes, right? And you can say, okay, which one is it, right? Which is an advantage. We couldn't do this if we were in class, right? You'd have to memorize them. So what do you guys have? What do you guys see? What angle relationship is that? All right. I'm getting some answers now. I need a few more. All right, so I'm getting a couple of different answers. So we got to be careful about this. you have to first look. See how angle 1, right? If we're looking at lines R and S, angle 1, you see how it's on the outside? Angle 2 would be on the inside, right? Angle 2 would be on the inside. But I'm glad that we're having this conversation, right? So it couldn't be consecutive interior because they're not both interior. And it couldn't be alternate interior because they're not both on the interior. It couldn't be alternate exterior because they're not both on the outside. That leaves only one, and that's corresponding. So let's see. This is in the upper left. This is in the upper left. So these would be corresponding angles. Okay. So now that we know they're corresponding angles, are they on parallel lines? Oh my gosh, they're on parallel lines. So if they're corresponding angles and we have parallel lines, we know that these two angles are going to be congruent. So that can be my third step. My third step can be angle 1 is congruent to angle 2. And my reason is if parallel lines, now check it out, if parallel lines, we sure have parallel lines, right? Line R and line S are parallel. So if parallel lines, then corresponding angles are congruent. And check it out. Isn't that what we're saying? So you always know which form of the rule you're using is correct because the conclusion is what you're stating and your hypothesis is already in your proof. Okay? And I hope this is helping, guys. I hope this is helping make sense. So now I know angle 1 is congruent to angle 2. So what I can do is, instead of having angle 1 equal to angle 3, I can replace it. And that's going to be my step 4. So I'm going to replace angle 1 with angle 2 in this top equation. I'm going to say angle 2 is congruent to angle 3. And all I'm doing here is that I'm replacing this angle 1 with angle 2. So the correct answer here would be substitution. But for my test, if you wrote transitive property, I would also give you points. Okay? I know some people on their midterm, they put like chain rule. I gave you points. Okay? But substitution is the right answer. Transitive is also a right answer. With big ideas, right? I'm pretty sure it's multiple choice. And you get unlimited guesses. So you guys can get there. Excuse me. All right. So take a look. 2 is congruent to angle 3. We got our goal, didn't we? So as soon as I reach my goal, now we're ready to finish, right? So I reached my goal, so I can say, hey, line J is parallel to line K. And my reason, well, I already wrote my reason up here, right? It's going to be if alternate exterior angles are congruent, then parallel lines. And again, where do we have alternate exterior angles are congruent? We have it right there, right? These are alternate exterior angles that are congruent. And then parallel lines is my statement. Okay? So I would be done with this proof. So again, this is just a recap of what we did last class. Okay? And I always want, if you guys are struggling with homework, make sure you guys are sending me emails. I can help you out. Make sure you tell me what assignment you're working on, what problem you're stuck on, or else I won't know how to help you. And remember that there's no penalty for late work. But if you are turning in late work, you should send me an email because I don't get a notification from Big Ideas that you completed an assignment, okay? And saying submit on Google Classroom does nothing for me because you can hit submit at any time. So it doesn't mean that you got points. So you guys make sure you email me, send me an email and just be like, hey, Kraft, I finished this assignment. Please update Skyward. And I'll be like, sweet. Thank you for emailing me. All right. Hey, let's do some new stuff today then. And remember, if you guys have questions, to go ahead and ask at any point. Okay. So we're doing some new stuff today. We're going to be starting in chapter 4. So if you're following along with the book. And chapter 4 is all about transformations. Okay? Transformations. Now, as you write down the word transformations, you might be thinking, man, that sounds a lot like Transformers. Boom. Absolutely. Transformers are from transformations. Okay? So if you think of a transformer is like a robot that switches shape. right? It goes from being a vehicle to this big, like, action fighting robot. Okay, so that's that. Now, transformations isn't literally going from a vehicle to a crime fighting robot. It's just a transformation is change. Okay, and for our class, we can think of it as a change of shapes. Now, that's not the technical definition of transformations, but it's going to be just fine for us. Okay, it's shapes changing. Okay, now there's different types of transformations. We're only going to focus on one today, and as you saw from the intro, it's going to be translations. Okay, so let's take a look at translations. This is what we're looking at today. So translations. Okay, now you might be like, what? Like, translations is when you go from one language to another. Right, and that's when we're talking about language. So translations for shapes is a little bit different. Okay, so when I say translation, we're not going to be going between languages. So translation here means that we're going to move a shape up or down or left and right. Oops, I'm off the screen a little bit. Sorry about that. So a translation is when we move a shape up or down, left or right. So if you guys played video games at all, if you look at the directional pad on a controller, right? That's what we're going to be doing. Up, down, left, right. Now, some of you might be like, well, my video games has a joystick. Cool. But that gets more complex because then you're moving at angles, right? So you're going to learn that math next trimester. Well, the intro to that math next trimester with trigonometry. Okay? And then you really learn it, like how to program it and how to do all of that in pre-calculus. Okay? So this is just an intro to some basic translations. We're just going to be going up, down, left, or right. Okay? And you can get more complex later. Now, one other note here that I want to say. We're talking about rigid motions only. So rigid motions only. Okay? So when I say rigid just means the shape stays the same. Same size, same shape. Okay? So same size, same shape. That's what's going on here. So we're going to be doing rigid motions only. So same size, same shape. And remember, the fancy word for that is congruent. Okay? So we're going to do translations, but we're only going to be moving shapes up, down, left, right, and it's only going to be rigid motion. Okay. So what we're going to do, now we don't have access to graphing paper. So we're going to do our best without graphing paper, but because we don't have graphing paper, we're going to have to be a little creative. And so we're going to have to do this less with our eyes and our fingers and more with algebra stuff. So before I do this, it's going to be hard for me to set this up. So I want you to bear with me a little bit. We're going to take some notes, and then I'm going to spend the rest of the time doing application of it. So just let's take some notes, and then you'll see what I'm talking about. Now, when you're moving something, you're going to end up with a starting shape and an end shape. So I like to call this the original shape. Okay, and then let's leave some space to take some notes, and then you have the new shape. Oh my gosh, I'm really dry in my throat. All right, so now it would make a lot of sense if we just used this language, original shape, new shape. But unfortunately, the book and mathematicians use different language. So the original shape is referred to as the pre-image. The new shape is referred to as the image. And you guys are going to see what that means in a little bit. But when you hear me say image, pre-image, now if you're thinking about a video game, your original game, and then you hit your directional pad and your character moves, and where your character ends up, that's your new image. Okay? So you have a start and you have an end. And I'll show you what this looks like in a little bit. But that's what I'm saying with pre-image and image. And the book uses this language. So get this in your notes. Okay? Because it might say, given the image, find the pre-image. So that's going backwards. Or it might say, given the pre-image, find the image. Right? So that's going forwards. Okay? So so the next thing is notation. Okay? Okay, so let's do a notation example. So let's say I have triangle ABC. Now this might be confusing for some people because the triangle in algebra, didn't that mean change in? It meant delta, right? So in geometry, this is just gonna read triangle. Okay, so I have triangle ABC. It's just naming the triangle. So I have triangle ABC. Okay, and triangle ABC is our pre-image. Okay. Now, we're going to transform this, right? So if this was a transformer, this is my car, right? And I'm going to go and I'm going to get a new shape. Now, the new shape is going to be really confusing if we call it the same thing. So we need notation to say, hey, something happened to it. So what they're going to do here is they're going to go A, and then they're going to put a little tick mark up here, like the closest you can get on a keyboard is an apostrophe. So we call this A prime, B prime, and C prime. Okay, and I'm going to write that out in English in just a second. So I go A prime, B prime, C prime, and this is our image. Okay, and in English, this would read as triangle A prime, B prime, C prime. Right? Like Amazon Prime. Okay? And Amazon, right, got that because they're a shipping company. So it's good. I mean, it makes sense that they're prime because they're moving things, right? So Amazon Prime. Okay? They move things. So this is triangle A prime, B prime, C prime. Okay? And all this tells us is that we have moved one time. Okay? And I'll show you more examples of that in a little bit. Okay? So now that we have this vocab and we have this notation, I'm going to show you guys an image. And you don't need to copy this image down. We don't have graph paper. I just want to look at it and talk about it with you guys. Okay, and this is from the book. That looks really blurry. There we go. All right. So, looking at this image, you're looking at two shapes. Now, they happen to be two different colors, and we're not going to always have two different colored shapes. But what I want you to notice is which shape is the pre-image. Okay, and you can just do color. What color shape is the pre-image, is the original shape? What color? And in chat, just type it in. What color is the pre-image, the original shape? And I should have 33 responses, guys. Okay, so it looks like I'm getting a mix between red and blue. Okay, so again, the pre-image is just going to be triangle ABC. So if I get my little coloring thing here and I go to blue, I'm going to, ooh, that was awfully thick. I don't need it that thick. So right here in blue, this is my pre-image. Oh my gosh, writing with a mouse. Okay, this is my pre-image. And we know it's my pre-image because there's no prime marks. Okay, there's no prime marks. Okay, then I have this right here. Do you guys notice the prime marks, right? I have A prime, B prime. This is my image. Okay, now it looks smaller, right? So you might say that, but let's do some measuring. If I look at CB, How long is that? 1, 2, 3. How long is CB here? 1, 2, 3. Right? So it might have an optical illusion of looking smaller, but these are the same triangle. This is rigid motion. Okay? So what we're going to talk about next is we want to talk about how they moved, right? So to talk about how they moved, what we're going to do is we're going to start with point A. Okay? Now, we know that blue is my original image. So to get from A to A prime, I had to go up 1 and I had to go left 3. You guys agree with that? So from A, I had to go up 1, left 3 to get to A prime. Now let's take a look at C. At C, I'd have to go up 1 and then left 3. So again, -3, up 1. From B, I'd have to go up 1 and left 3. Now, if we all had graphing paper, this would be really easy for all of us to do. But what's important here is that see how every point is moving the same amount. All 3 points are moving up 1, left 3. Okay? So all points are moving left 1, up 3. Okay? You know what? Know what I just think? I think I counted wrong. Oh my gosh, that's embarrassing. I think it's left 4. Yeah. Thank you. I got it. Hey, easy fix. Oh my gosh, that's not an easy fix. Here, left 4. I swear I can count, guys. I swear as a math teacher that I can count. Okay, there, that looks a lot better, doesn't it? Okay, so I'm going left 1, 2, right? And then, so remember, this is 1, 2, 3, 4, right? And then here I'm going 1, 2, 3, 4, and here I'm going 1, 2, 3, 4. So I'm going 4 to the left and up 1. Okay? All right. So I'm going to clear all of that. Give me just a second. Oh, here, I'm just going to erase it. All right. So I'm going to unfreeze here. And then I'm going to zoom out. So let me just sketch this really quick. So what we need is we need a mathematical way to communicate that change, right? So to do this, I'm just going to really quickly sketch this. You don't need to do this if you don't want to. So I have boom, boom, boom. So I had A, B, and C. And then I had up here, I had A, B, and C. Okay. And what was happening, right? So I'm just recapping this. So this was up 1, left 4. This was up 1, left 4, right? This is kind of what we had again. I'm just sketching a picture. Okay. So we want to be able to communicate what happened here. Okay. So what we're going to have then is we're going to have a formula for translations. Okay. So in your notes, this is what you're going to be referring back to all the time. So we're going to have a formula for translations. So what I'm going to do, because this is going to be in a math language, is I'm going to write it out first in a math language, and then I'm going to write it in English underneath. Okay? So in math language, here's the formula. It is point XY, and then an arrow going to the right, and then parentheses, x plus a, y plus b. You're like, what the heck? You just gave me a cheat code for a video game. All right, so what does this mean in English? This means every point, that's what this means right here. Every point, right? Because x and y represent all numbers, right? So every point such that, that's what the arrow means. So every point such that, and that's an H, not a K, right? That'd be inappropriate. Every point such that, okay? And then the last part reads x plus or minus some number and y plus or minus some number. Okay, so it's every point such that x plus or minus some number and y plus or minus some number. So using this example, I'm going to write this out in math language. Okay. So in math language, how do we write this transformation? So am I going too fast? I'm going to slow down just a second. Make sure you guys get this down. So this is the formula, and this is what it means in English. So every point xy such that x plus or minus some amount, y plus or minus some amount. Okay. Now, for this case, what's happening here is I'm taking every point, right? I took every point on my original. Oops. I should have the little prime, shouldn't I? I didn't include that, right? Because this is prime. The second shape is, that's how we know what shape was my original. So I'm going to take every point on my original such that, so what happened in the x direction, right? In the x direction, I moved left 4. So I'm going to say x minus 4. And then what did I do in my y direction? I went y plus 1. Right? So underneath this, you might say we went left 4, up 1. Okay, and that's it. This is how you would if you guys are programmers, right? This is how you would program a video game with an input. You have an input that takes all of your points, right? Because remember, video games, all your characters have points on them. If it's just an image, then the image itself would move, right? So like if you're just pasting in a picture of your head, then your head would move this much when you hit a certain input. Okay, kind of cool, right? So that's what a translation is. Okay, so now what we're going to do with the time that we have left, we're going to take a look at 2 examples of how to do translations. So this is the formula that we have. It's going to take the original points and move them like this. So again, how do you know which one's the original? Your original is going to have no primes. Your image is going to have primes, right? And the primes means I have moved this 1 time. Okay, so I moved my original shape 1 time. And then that way, we can keep track of multiple transformations. And that's what we'll get to at the end. Okay, so let's do a practice of this. And if you guys have questions, please let me know. Oh, I did this on a piece of scrap paper. Get a fresh start here. All right, so let's do an example. Okay. Let's do an example together. So our example here, I'm going to zoom out just a little bit. Oop, I zoomed in. So we're going to do an example here. So let's say given shape A, B, C, D. So this one isn't a triangle because it has 4 points. So given a shape with 4 points, that's basically what this is saying. A, B, C, and D with vertices. And if you forgot what the word vertices meant, vertices is just a fancy word for point. Okay? So what it's saying in plain English is given shape ABC with points. And then I'm going to have coordinates. So A is going to have coordinates -1, 2. Okay? And then I put a comma and I say B is going to have the coordinates -1, 5. And then I put a comma. And then I have C is 4, 6. And then I put a comma. And then D is going to be at 4, 2. Okay, so given shape ABCD with these coordinates. Okay, that's our start. Okay, that's our start. And what we're going to do is, and we're going to focus on without graph paper because we don't have graph paper. We're going to apply the translation Okay, so we're going to apply the translation, and I'm going to have xy, point xy, such that, right, every point such that I'm going to have x plus 2 and y minus 3. Okay, so there is our problem. So how are we going to do this without a picture? Well, this is what a computer does, right? Or a video game, this is what it does to get movement. So some things I want you to point out. Notice how it says every point x, y. Well, remember, all of these are points x and y, right? And you see for each point, our x and y changes. So what we're going to do is we're going to take these points, and one at a time, we're going to plug them in to this formula. Okay, so let's do the first one together, and you'll see what I mean. So my first answer is going to be my new a. So my new a is going to be a prime, right? Do you see how I put the prime there? This is my new a. So my new a, well, what am I going to do to get my new a? I'm going to take my old x, and I'm going to add 2. Do you guys see where I'm getting the 2? So I'm going to take my old x, and I'm going to add 2. And then I'm going to take my old y, and I'm going to subtract 3. Right? And this is my work for a prime. So I take my old a x, and I add 2, and I take my old y, and I subtract 3. You guys see how this formula is working? So if I have -1 plus 2, that's 1. And if I have 2 minus 3, that's -1. And that's it. You got your first point. Okay? So we're going to repeat this process for B, C, and D. Now, if I've confused you or you're lost, make sure you ask a question now. Okay? So I'm going to get B prime, because remember, this stands for all points, right? So I'm going to have to do... Okay, so I'm taking these 4 points, and I'm applying this translation, right? So I'm going to take this whole shape, and I'm going to move it this, right? So what's this moving? I'm going to go right 2. I'm going to go down 3. Okay, so I start with my original A. So see how it says x plus 2, y minus 3? Okay, so what's my original x? -1. Right, so I took -1. See how I put that in red? And then I'm going to add 2. And I put that in blue because that's my formula. So right, so in our problem, we were given shape A, B, C, D. So this is my pre-image. This is my original. And so I'm going to apply this translation to get my image, my new shape. You got it. There you go. Okay. Yep, I'm glad you asked. And then for B, right, I'm going to show my work one more time with this one. So for B, I'm going to take my original x. I'm going to add 2. And then I'm going to take my original y, and I'm going to subtract 3. Now, in this case, the x is the same, right? So -1 plus 2, that's going to be +1. And then 5 minus 3, that is 2, right? So I'm finding the coordinates for my new shape. Okay. So then I can do this for C prime. So I'm going to have 4 plus 2, that's 6. I'm going to have 6 minus 3, that's 3. And then D prime, I can have 4 plus 2, that's 6. And then 2 minus 3, that's -1. Right? This is my image or new shape. It's not really a new shape, right? Because it's going to be the same size and same shape. So when we say new shape, it's really its new position. Okay? So we started out with A, B, C, D. We did this translation. This is the new location of our shape. Okay? So in your homework, you're going to have a problem like that where it's going to give you a shape and then you're going to have to find the image. Now, on your homework, it might, so I'm really glad that the question was asked, right? The question was asked like, is this our image or our pre-image? So they might give you a translation, an equation, but they might give you D prime and say, what's the pre-image? So think about that. If you start with your image and you're going to your pre-image, aren't you going backwards? So look at this formula. It works backwards too. So if I'm at 6, -1, and I want to get to D, I'm going to do this backwards. So what's backwards of +2? It will be -2. So 6 minus 2 is 4. You guys see how that works? So if you're going backwards, you just do everything in your translation backwards, right? So instead of going down 3, I would go up 3. Okay, so there is one question on your homework that's going to ask you to go backwards. So just remember, if you're going backwards, then do your operations backwards. Okay? So flipping the signs would be the backwards, right? Yeah. Right, but what you're doing right there is exactly the opposite, because the opposite of positive is negative, and the opposite of, yeah, so you got it. You're doing the right thing. Okay, so that's going to be one part of your homework, guys. You're going to be given a shape, and you're going to want to find, hey, if I do this translation, where's it going to end up? Okay, very important skill. It's a very basic intro. I know it's not super sexy, and you guys are like, I want sexy math. It's not super sexy yet because we're going to have to practice the basics. Okay, so the other thing that I only have 8 minutes. The other thing that we need to talk about is composite transformations. Okay, so we're going to talk about composite transformations. Now, some of you might have heard of the word composite before. Composite means 2 or more. So you might heard of like a composite metal or a composite plastic. That just means it's a plastic or metal made up of 2 or more different types of metals and plastics. Okay, so transformations. Okay, now the only key here that I want to point out with composite transformations, you must go in order. What sometimes I have students do is they're like, oh, I'll just do the one that's easiest first. You can't do that. You have to go in order. So if it says transformation 1, then transformation 2, you have to do the first one first. Okay? So that's really the biggest takeaway here. You have to go in order. Okay, guys? You have to go in order. Okay? You must. So to teach this, because I don't have a lot of time, we're just going to do an example. And I'm going to have to speed up a little bit because we're running out of time. So we're going to do this example with, instead of a 3-dimension or a 2-dimension, instead of a closed shape, we're just going to do a segment. So we're going to do segment RS such that R is at -8, 5, and S is at -6 and 9. 8, not 9. Oh my gosh, my Spanish. I haven't used Spanish in a long enough time where I'm starting to lose my Spanish. That's not good. So I have -8, 5, -6, and 8. Okay, and we're gonna have 2 translations, and I'm gonna color them to help you out. So we're gonna translate, and my equation is every point xy such that x plus 5, y minus 2. And then my second one, we're going to translate every point xy such that x minus 4 and y minus 2. Okay, so there's our problem, and then I'm going to show our work. Now, this isn't a very exciting composite because you're just moving twice. So like in a video game, you'd want your character to jump up, maybe do a forward rotation, and then fall back down, right? Because that's really cool in video games, right? So, but we're going to learn about rotations in an upcoming class, okay? So, we have two transformations. We have to go in order. That means I have to do this first translation first. So, I have to do number 1 first. And what's happening here is I'm taking my original, right? I'm taking my original and I am going to R prime, S prime. Okay, so I'm going from my original segment RS and I'm going to my new R prime, S prime, right? My segment R prime, S prime. Okay, so to do this, I'm going to have to find R prime. So remember, I'm going to take my original my R, and I'm going to put it into my formula. So here, I have -8 plus 5, right? You guys see that? I'm going to take this and plug it in here, and I'm going to take my 5 and plug it in there. So I go, okay, what's -8 plus 5? -8 plus 5 is -3, and then 5 minus 2 is +3. Okay, and then I'm going to find my S prime by taking these, right? So I'm going to take -6 and plug it in for X, and I'm going to take 8, oops, not plug it in for 2 though. I'm going to take 8 and plug it in for Y. So I'm going to get -6 plus 5 is -1, and then 8 minus 2 is +6. Okay, so there it is. Those are my coordinates for my new one. I moved it. Okay, now this is where the next part, this is where people can get, this is where you have to be careful. What's happening in step 2? We're not going back, we're not teleporting back to our original position, right? If you did that in a video game, that would be really weird, right? Every time you hit a direction, you just teleport back to the start. Okay, what we're doing is we're starting from our last position. And our last position was segment R prime, S prime. And what we're going to is our second position. So that's going to be R double prime, S double prime. Okay, and notice how these little tick marks up here, they tell us how many times we've moved. So I went from my original to R prime, S prime, and then now I'm going from R prime, S prime to R double prime, S double prime. Okay, and you guessed it, if there was a third, it would be triple prime. Okay, so what we have here, so to get R double prime, I'm going to take this coordinate and I'm going to plug it into my new one here. So again, I'm going to take my X here and I'm going to take my Y here. Okay, so what do we get? So I have -3 minus 4, that's -7. And then I have 3 minus 2, that's 1. Okay, and then S double prime, I'm going to start from my S prime. So I'm going to have -1 minus 4, that's -5. And then I'm going to have 6 minus 2, that's 4. Okay, this is my final resting place. So I went from my start place to my final resting place here in 2 moves. Okay, now I'm just going to sketch this because if we were doing this on graph paper, we'd have images, right? So I just want to show you, and this is just a rough sketch. And so you guys don't need to really worry about it. So RS, my original, would have looked something like this. And then I moved it right 5 down 2. So I'd go right 5 down 2. Right? So we went right 5 down 2. And then my last one, I go left 4 down 2. So I'd be almost back to the original and down 2. Oops, down 2. Right, so I forgot to add my primes, right? So that's R double prime, this is R prime, and S prime. Okay, and again, this is just a sketch. It's not accurate, but if we were in person, we would be doing this like that. So that is a composite transformation. Okay, it had 2 different translations. I moved here first, and then I moved down here. And this is my final resting space. All right, guys, that's it for